Welcome students. In this session, we look into the topic insulating materials. Insulating materials are those which obstruct the flow of current. They form ionic bonds. They have low conductivity of the order of 10 to the power of minus 18 to 10 to the power of minus 10 mho per centimeter, and they have high resistivity of the order of 10 to the power of 12 to 10 to the power of 18 ohm meters. They are available in solid, liquid and gaseous forms in large varieties like plastic used for plug, porcelain used for overhead transmission lines, insulating oil used in transformers, air used between the conductors in overhead transmission lines, and also in all domestic and commercial electrical equipment to isolate the conductor from earth or body. The insulating materials offer very high resistance to the flow of electric current. They require extremely high voltage of the order of kilo or megavolts to send a few milliamperes of current through them. In ideal insulators, static electric field penetrates uniformly. Insulators are used primarily for storage and also in all domestic and commercial electric equipment to isolate the conductor from earth or body. The main topics to be discussed today are the introduction to insulators, the various properties of insulating materials, the factors affecting the properties, the classification of insulating materials, and the different types of insulating materials. The first topic under discussion is the introduction to insulators. The insulators are the materials which have the atoms having the valence electrons 8 or nearer to 8. They are in the most stable condition. When the valence electrons are 8, obviously the atom is in a stable condition. They offer very high resistance as there are no free electrons. Also, the forbidden energy gap between the valency band and the conduction band is more. For the electrons to jump from the valency band into the conduction band, you need to give lots of energy, and hence the forbidden energy gap is more. So, the static electric energy penetrates uniformly in them. Now we will see here the atomic structure of an insulating material called neon. Here the atom has 8 electrons in its valence shell, that is the outermost orbit, and hence it is stable. It can be considered as an insulator. Also, the atoms like fluorine which have 7 electrons in their outermost orbit in the valence shell can be classified as a insulators, because when they don't have any free electrons. Also, the atoms like oxygen which have only 6 electrons in the valence electron, they can also be classified as insulator, but the insulating properties of oxygen is less than that of fluorine and neon. The atoms having 8 electrons and 7 electrons in the outermost orbit behave as good insulators compared to the atoms having 6 valence electrons. Now we will look into the energy bands of the different types of materials like conductors, semiconductors and insulators. The conductors are the materials which allow the current to flow through them. Hence, the valency band and the conduction band overlap. in case of semiconductors, for the electrons to jump from the valency band to conduction band, you need to give only small amount of energy, hence there arises a forbidden gap. This gap is less. In case of semiconductors, we have 4 valence electrons. So, for the electrons to be removed from the outermost orbit or to come from valency band to the conduction band, the gap is less. But in case of insulators which have almost filled outermost orbits, for the electrons to be jumped from valency band to conduction band, the energy to be supplied is much higher. Hence we see here the forbidden gap is more in case of insulators as compared to semiconductors. Of course, in case of conductors, both the conduction band and the valency band overlap. The insulating materials offer very high resistance to the flow of electric current. They require extremely high voltage of the order of kilo or megavolts to send a few amperes of current through them. In ideal insulators, static electric field penetrates uniformly. Insulators are used primarily for storage of electric energy as in capacitors and are known as dielectrics, but when used to prevent the leakage of current to any undesired conducting medium, they are known as insulators. Almost all the insulating materials have negative temperature coefficients of resistance, and as such their resistivity is reduced with increasing temperature. The function of insulator is very important, without which no electrical machine can work. Majority of the breakdown in the field of electrical engineering is due to the failure of insulation. The importance of insulation material is ever increasing day by day, as there are innumerable number of types of insulators available in the market. The selection of a right type of insulating material for a particular job is very important, because the life of the equipment will depend on the type of insulating material used. All the insulators, when used, should not only behave as insulators over a wide range of electric voltage, but must be strong enough mechanically, should not get affected by heat, atmosphere, chemical effects, and should be free from deformation due to aging. Therefore, before selecting an insulating material, it is quite essential to know its various properties and their effects on insulation. Now, we look into the various properties of insulating materials. The various properties of insulating materials are electrical properties, visual properties, that is how they appear, the mechanical properties, that is their strength, the thermal properties, that is their heat resistance, and also the chemical properties, their reaction with the other atoms. Right. Now, we look into each of these properties in detail. First one is the electrical properties of insulating materials. The electrical properties of insulating materials can be divided into two, that is insulating resistance and dielectric strength. Again, the insulating resistance can be studied as the volume resistance and surface resistance. The insulating resistance is the property of an insulating material by virtue of which it resists the flow of electric current through it, that is by the property by which it will not allow the current to flow through it. It is of two types. One is volume resistance and the other is surface resistance. Volume resistance is the resistance offered to the current which flows through unit cube of the material. It is measured in ohm meter. The surface resistance is the resistance offered to the current which flows over the surface of the material. It is measured in ohm per square meter. The factors affecting the insulating resistance are the temperature, moisture, applied voltage and aging. Now we will see how these factors affect insulating resistance. First is temperature. The temperature affects the insulating resistance of a material. Here we see when the temperature is less, the resistance of the material is high. As the temperature goes on increasing, the resistance goes on decreasing. This is in case of insulators, and hence insulators are said to have negative temperature coefficient. Here we see in the graph, when the temperature is less, the resistance is high. It goes on decreasing as the temperature increases. Moisture decreases the surface resistance and causes insulation breakdown when insulators are exposed to moisture. The next factor is applied voltage. The insulation resistance varies with the change in applied voltage above a certain potential. The other factor is aging. As the insulation serves for a longer period, its resistance decreases with the age of service. This is known as aging. For example, the life of an underground paper insulated cable is about 50 years. It means it tends to deteriorate after 50 years. The next factor affecting insulating resistance is dielectric strength. Every electrical apparatus is designed so as to work within a defined range of voltage. If the operating voltage is increased gradually, then at some value of voltage a breakdown will occur, puncturing the insulation permanently. The dielectric strength or breakdown voltage is the minimum voltage which, when applied to any insulating material, will result in the destruction of its insulating properties. It is expressed in kilovolt per centimeter or kilovolts per millimeter. For example, the breakdown voltage of air is 30 kilovolts per centimeter. It means that the maximum voltage 1 centimeter of air can withstand is 30 kilovolts. Right? Now we will see the factors affecting dielectric strength. The factors affecting dielectric strength are temperature, humidity. First, when the air is used as a dielectric, the dielectric strength decreases when the temperature is increased. When the temperature increases, the dielectric strength of the material decreases when air is used as an insulator. But for a liquid dielectric, the effect varies with the type of the oil and its viscosity. It depends upon the type of the oil and its viscosity of the liquid. The next factor affecting dielectric strength is humidity. It decreases the value of dielectric strength. When there is a humidity present, the humidity present decreases the value of the dielectric strength of the insulator. Now we will see what is dielectric loss. When AC voltage is impressed on the insulating material, the loss appearing in the form of heat due to the reversal of electric stresses leading to the molecular rearrangement is known as dielectric loss. So, when AC voltage is applied, because of its positive and negative nature, there will be reversals of molecular arrangement and hence heat is developed due to collision of molecules. The heat loss due to this is called dielectric loss. Now we look into the visual properties of insulating material. The visual properties of insulating material are appearance, color and its crystallinity. Now we look into the mechanical properties of insulating materials. The mechanical properties such as impact strength, tensile strength, toughness, hardness, elongation, flexibility, abrasion resistance, etc. have to be considered when choosing an insulating material. Also, the machinability and resistance to splitting are equally important. In case of varnished products, the bonding property of varnish is important. Some of the mechanical properties which are to be taken care of while selecting the insulating material are: first is tension and compression, the next is resistance to abrasion, tear, shear and impact, the next is viscosity, porosity, solubility, moisture absorption, machinability and moldability. We look into each of these in detail. Tension and compression. The conductors of transmission and distribution system and overhead lines are supported by means of insulators to avoid leakage of current through the supports to the earth. When a tension exists on it, it should be able to withstand and should not give away mechanically. The next factor is resistance to abrasion, tear, shear and impact. Take the case of an insulator used between the commutator segments, which are subjected to abrasive action, that is, the effect of the insulation caused by scraping during the running of the motor. The insulating material must be able to withstand these forces, hence it should be hard and mechanically strong. In case of insulation materials which are subjected to tear, shear or impact, the damage caused to them will completely put the system out of control and sometimes out of stability. In such cases, the insulating material should be capable of withstanding all such forces. The next mechanical property is viscosity. In liquid insulators, viscosity plays an important role. It affects the manufacturing process. For example, in paper insulated cables, the temperature at which the oil penetrates through the paper will depend on its viscosity. Low viscosity liquids are more mobile and hence helps in transmission of heat by easy circulation, as in the case of power transformers and switchgears. Liquid insulators should not contain impurities, as it will also affect the viscosity and the performance. Now the next mechanical property is porosity. In solid insulators like pole insulators used for transmission and distribution lines, high porosity will increase the moisture holding capacity, which is not a desired quality because it adversely affects the electrical properties of the insulator. Therefore, high porosity is not a desired factor, but in certain other applications like in paper, which is to be impregnated with oil to increase its insulating properties or to improve its insulating capacity, high porosity is desirable and advantageous. Therefore, this factor should be visualized with respect to application. The next mechanical property is solubility. Certain insulating materials like varnish should be applied only after it is dissolved in proper solvents like acetone. In such cases, insulating materials should be soluble in certain suitable solvents, but it should not be soluble in water. Otherwise, the moisture of atmosphere will be able to remove the applied insulation and cause breakdown. The next factor to be considered is moisture absorption. The insulating material should not absorb moisture, as moisture lowers the electrical resistance and dielectric strength. Due to this, certain chemical and mechanical effects like swelling, wrapping is something becoming bent or twisted from the original shape, or corrosion may also occur. The insulating materials should not absorb moisture, but even if it is so, it should be as low as possible without disturbing its electrical characteristics. The last factor to be considered is machinability and moldability. In the manufacturing of solid insulating material, it should have the property of being easily molded and machined into a required shape and size. The thermal properties of insulating material are: the insulating materials must be stable within the allowed temperatures. Certain materials like waxes, plastics, bitumen compounds and resins are softened at low temperatures. This may cause deterioration of mechanical properties and the insulation may melt out of the coil windings, etc., causing internal short circuits. Some of the thermal properties are melting point, flash point, volatility, thermal conductivity, thermal expansion and heat resistance. Right. We will look into each of these in detail. Melting point. The melting point of liquid dielectric used in solids should be sufficiently high. Melting point is important in specific cases like non-draining compound paper, insulating cable. It is desired that in entire operating range of cables, the impregnated compound must not melt. The next thermal property is flash point. This is an important factor when selecting oils for transformers and switch gears and other oil immersed apparatus. An insulating material should not catch fire at the operating temperature. The flash point of a liquid dielectric is that temperature at which the liquid begins to ignite. The next property is volatility. A volatile material cannot act as a good insulator. When a trapped gas is evolved from a volatile insulating material subjected to volatile stress, the breakdown of insulation is accelerated. Hence, the material used for insulation should not exhibit volatile property. Next is thermal conductivity. During the thermal operation, heat is generated due to copper losses within the conductor and its dielectric losses within the insulator. The entire heat produced should be transferred to the outside atmosphere so as to maintain the operating temperatures within the limits. Hence, an insulator that is used should have very low thermal conductivity, especially in high voltage apparatus where the thickness of insulation is more. The next is thermal expansion. Due to repeated and rapid load cycles to an equipment, corresponding expansion and contraction of the insulator occurs, leading to the possibility to the formation of voids. When two insulating materials combine to form an insulating system, due to two different coefficients of thermal expansion, formation of voids is inevitable. This void formation plays a major role in the breakdown phenomena. The next factor is heat resistance. The insulating material used must be able to withstand the heat produced due to continuous operation and remain stable during the operation. This property is known as heat resisting property. It should at the same time not get damaged, or it should not damage the other desired properties. Only then current loading can be increased, thereby making the apparatus capable of holding more power. The next is The chemical properties of insulating materials. The various chemical properties of insulating materials are resistance to external chemical effects, effects on other materials like how the insulating material gets affected by the other materials nearby, the chemical changes in the material, hygroscopicity and aging. Right? We look into each one of them. The resistance to external chemical effects. Insulating material should be chemically stable and offer chemical resistance to oils, solvents, acids, alkalis, and oxidation and hydrolysis should not occur in the insulation even under adverse conditions. Effects on other materials. The effects on materials in contact with the insulator should not be damaging and they should not have any direct solvent action on this material. The next is chemical changes in the material. Certain chemical changes may take place in the material itself during use, but its properties should not deteriorate. For example, oxidation included in varnish from dryers, acidity in oils, paper and cotton, chemical instability in synthetic resins or vulcanization of rubber. Hygroscopicity. Many insulators come in contact with atmosphere either during manufacture or during operation or both. The contact of insulation with atmosphere is often so complete that even the less chemically aggressive atmosphere can prove a threat to smooth running apparatus. The last factor is aging. Aging is the long-term effect of heat, chemical action and voltage application. These factors decide the natural life of insulators and hence or of an electrical apparatus. So far in this session we have seen what are insulating materials, their properties and the factors affecting the various properties. Okay students, till we meet again, goodbye.
Further clarification, contact the Additional Secretary, State Board of Technical Education and Training, 7th floor, BRKR Bhavan, Tank Bund Road, Hyderabad 500063. Fax 040 322 0546.